All right, let's take a look at the last two examples in this geometric sequence section. So example 1.3.4, in a geometric sequence, that means it's going to have a common ratio. What do we know? The second term is 28, and we know that the fifth term is 1792. We're asked to determine the values of T1 and R and list the first three terms of the sequence. All right, so the first thing that we need to do is we need to examine this sequence a little bit. So I'm going to build a chart to examine the sequence. Term 1, I don't know. But I do know that term 2 is 28. I know that term 3 is I don't know. Term 4 is I don't know. And term 5 is 1792. All right, so let's take a look here. We've got two pieces of data. And we are going to use our formulas to analyze those two pieces of data. So the first one is going to be, well, I'm just going to write out our formula here for the nth term is equal to term 1 times our common ratio to the n minus 1. So we're going to start off with our second term right here. So our second term, n is equal to 2. And our nth term is 28. That's our second term. It's equal to term 1, which we don't know. Our common ratio, which we don't know, to the power of 2 minus 1. Simplifying this equation a little bit, I get 28 is equal to our first term times r to the power of 1. I don't know what r is. I don't know what term 1 is. I have two variables here that are missing. So now let's go over to term 5. Now let's do the same thing. So n is equal to 5. We have 1792 is equal to term 1 times the common ratio to the power of 5 minus 1. So 1792 is equal to term 1 times r to the power of 4. Now if we look here, I have two equations, and I have two unknowns. So I can solve these through substitution or elimination or graphing if you want to graph them. But because they're multiplied together, elimination doesn't work too well. I need to do substitution. So I need to find a variable that I can isolate. Well, there's a lot of variables that I can isolate pretty easily. The one that I want to isolate is term 1. So we can isolate term 1 here. So to isolate term 1, I just divide both sides by r to the power of 1, which is just r. And I get term 1 is equal to 28 divided by r. Now that I know what term 1 equals, I can replace this term 1 over here with this. So I'm going to take my 1792 is equal to term 1 is now 28 divided by r, times that by r to the power of 4. Now, with these variables, this is going to cancel one of these, and we're going to be left with 1792 is equal to 28 r to the power of 3. Divide both sides by 28. I get r cubed is equal to 1792. I'm going to go to decimals on my computer here. You won't be able to see it. Divided by 28. I get 64. Excuse me. Now I simply cube root it. And I get r is equal to 4. So I now know my common ratio is equal to 4. Now, if I take this 4 and I throw it into one of these equations right here, I can figure out my term 1. So 28 divided by 4 is equal to term 1. Term 1 is obviously equal to 7. So my sequence is going to go, my geometric sequence goes 7, 28, then 28 times 7 is, or sorry, 28 times 4. I got to figure that out. $112, $448, $1792, dot, dot, dot. All right, that's how you determine the common ratio and term 1 of a geometric sequence if you know 2 terms in it.